Hi students, welcome to Max Point of View. Today we are going to solve each and every question from Uniform Circular Motion chapter exercise part. Okay, in exercise what are the questions are there, we are going to solve each and everything. I think you have seen my explanation video. If you have seen that, then this session will be a very easy session for you. If you haven't seen it, the video will be available in the description box. Go learn and come, and then I think you can answer all the questions without my help. Okay, now for few people when it comes to give reason questions, they'll face some difficulty, right? Only for that we are creating these kind of videos. Is it possible to have an accelerated motion with a constant speed? Name such type of motion. Very simple example. Yes, it is possible, correct? Because when an object is moving in a circular path, speed remains same. But what about velocity? Velocity depends upon the direction. At each and every point, velocity changes. Why? Because at each and every point direction is changing. If the direction changes, velocity also changes. So the answer is yes, it is possible. Example is uniform circular motion. Here they are just asking for an example. A simple example you can take: a cyclist cycling around a circular park. So this example is enough for this question. Name the force required for the circular motion. State its direction. Very simple. Whenever an object is moving in a circular path, the force required is centripetal force. Centripetal force. State its direction. For centripetal force, direction will be towards the center. The direction will be towards the center. That's it. Is centrifugal force is a real force? No, centrifugal force is not a real force. It is a fictitious force. What do you mean by fictitious force? It is not real, just an assumption. Differentiate between a uniform linear motion and uniform circular motion. See, when it comes to differentiation kind of questions, you can expect it for maximum 3 marks. For 3 marks, you have to write 3 points on each side. So, I will get full marks. Now, first point. Uniform linear motion. What do you mean by linear motion? A body or an object moves in a straight path. Moves in a straight path. When it comes to circular motion, a body moves in a circular path. Second point, for a uniform linear motion, both speed and velocity remain same. But when it comes to uniform circular motion, speed remains same, but velocity differs at each point. Okay, now the third point. Here, as the velocity remains same, in linear motion velocity is same, right? So acceleration will also remain same. Acceleration will also remain same. So we can tell this one as, so we can state this one as non-accelerated motion. There acceleration changes, so we can state there as accelerated motion. So 3 points are enough for this question. What is a centripetal force? Centripetal force is a force which acts on a body which is moving in a circular path in direction towards the center of the circular path. So this one we have learnt. This is a simple definition. Explain the motion of planets around the sun in a circular path. Okay, listen, these kind of questions will be asked for 2 marks. When you are writing the answers, we will be expecting 3 keywords. First is what force is that, who is providing that force, and what is the direction of that force. Okay, listen. So we clearly know that this is an example for centripetal force. Okay, what kind of force we can see here? Centripetal force. Who is providing that? Sun. What is the direction of the centripetal force? Towards the center of the sun. That's it. If you mention all these keywords in a proper sentence like this, okay, then that is enough. How does a centripetal force differ from a centrifugal force with reference to the direction in which they act? Okay, very simple question. See, when an object is rotating in a circular path, centripetal force will be towards the center. Centripetal force will be towards the center. Centrifugal force will be away from the center. It goes away from the center. You don't have to draw the diagram. If you write centripetal force is towards the center of the object, centrifugal force will be, the direction of centrifugal force will be away from the center of the object. Next sub question, is centrifugal force the force of reaction of the centripetal force? No. Answer is no. Why? Because see, what do you mean by reaction? Reaction means Newton's third law. Remember Newton's third law. When there is a action, there will be equal and opposite reaction. We know centripetal and centrifugal both are opposite in direction and they have same magnitude, but they are not the reaction of each other. Why? Because see, you take an example for Newton's third law. Okay, any example. Assume you have a gun in your hand. When you shot it, okay, bullet goes in this direction, gun comes in opposite direction, correct? So here we are talking about two different objects. Here we are talking about two different objects, one bullet and the gun. But when it comes to centripetal force and centrifugal force, we are going to talk about the same object, not two different objects. So centrifugal force is not a reaction force of centripetal force. Third one, compare the magnitudes of centripetal and centrifugal force. The magnitude of centripetal and centrifugal is same, but they differ in direction. This you should know. That's it. State two differences between centripetal and centrifugal force. See, I think this question or answer you can answer, but I'll answer. See, first thing is centripetal force. Centripetal force, the direction. We'll talk about the direction. Centripetal force, the direction will be towards the center. Towards the center. Centrifugal will be away from the center. Okay. Second point. Centripetal force is a real force. Real force. Centrifugal will be fictitious force. What is fictitious force? Fictitious means it is not real. It is just assumed force. Okay, now our first question. Explain the meaning of uniform circular motion. Why is such motion said to be accelerated? This answer you already know because we have taught this in the previous video. As I told you, that video is available in the description box. Okay, first we need to explain them. What do you mean by uniform circular motion? An object or a particle which is moving in a circular path with a constant speed. An object or a particle which is moving in a circular path with a constant speed is called uniform circular motion. Now they are asking why this uniform circular motion is an accelerated motion. If you have understood that concept video, then this is a very easy question. Listen, very simple. When an object is moving in a circular path, okay, the speed remains same. Speed remains same, but velocity changes at each and every point. Why? Because velocity depends upon direction. So at each and every point direction changes, so velocity changes. If the velocity changes, acceleration also changes. That is why uniform circular motion is called accelerated motion. Draw a neat label diagram for a particle moving in a circular path with a constant speed. In your diagram, show the direction of velocity at any instant. Very simple thing. Listen, we'll take this question as an example. We'll take 4 points. Okay, we'll name it as A, this is B, C, and this is D. At this point, assume the particle is moving now. At this point, the direction of the object or a particle will be in this direction. At B, the direction of the moving particle or a moving object will be in this direction. At C it will be here, at D it will be here. This is the diagram they are asking for. That is very simple question for 2 marks. Labeling is very much important. A uniform circular motion is an accelerated motion. Explain it. So a uniform circular motion is an accelerated motion. They are asking it why. Why? Because when an object or a particle is moving, okay, on a circular path, speed remains same. But what about velocity? Velocity is different at different point. Why? Because velocity depends upon the direction. At each and every point, direction changes, so velocity also changes. If velocity changes, what about acceleration? Acceleration depends upon velocity. So if velocity changes, acceleration also changes. That is why it is called as accelerated motion. Now they are asking state whether the acceleration is uniform or variable. Just now I told you velocity changes at every point, so acceleration changes at every point. So in this case, acceleration is not uniform, it is variable. Now the third sub question, name the force responsible to cause the acceleration. The force which is causing this acceleration is centripetal force. Centripetal force. Now the final one, what is the direction of force at any instant? Draw the diagram. You can take this diagram also. They are asking you to draw the direction of force. Direction of force. Which force we are talking about now? Centripetal force. You know centripetal force is always towards the center of the object, correct? So this is the direction of object moving, correct? Object moving. This will be the direction of force. That is nothing but direction of centripetal force. See, if you understand the question, how simple is to write the answers. A small pebble tied at one end of a string is placed near the periphery of a circular disc, at the center of which the other end of the string is tied to a peg. The disc is rotating about an axis passing through its center. Okay, now you need to understand the question. If you understand the question, then you can answer. First we will write what are the given data. Okay, assume a stone, a pebble. Okay, this pebble is attached to a string. One end of the string is tied to this pebble and this end of the string is connected to a peg. Okay, a peg of a circular disc connected here. Okay, and this circular disc, assume this is a circular disc. Okay, it is exactly like merry-go-round. This exactly circular disc is now rotating. Okay, now we will see the question. What will be your observation when you are standing outside the disc? Okay, what is your observation when you are standing outside the disc? Assume you are standing somewhere here. Okay, outside the merry-go-round. Okay, now see, if you are standing outside the disc, you see both this disc and the pebble are rotating in a circular path, are moving in a circular path, correct? So this is your observation. What about the second question? What will be your observation when you are standing at the center of the disc? Assume your Y now, you are standing on this disc, you are standing on this disc. Now what is your observation with respect to this pebble? So now if you are standing on this disc, you see this pebble which is attached to a string is stationary and it is moving along with you. So it is very stationary, it is not even moving. This is a very simple explanation which we have learned in the earlier video. A piece of stone tied at the end of a thread and is whirled in a horizontal circle with uniform speed by hand. Answer the following questions. First one, is the velocity of stone uniform or variable? First we will draw the diagram. Okay, a stone, okay, which is tied to a string and it is held by a person. And it is rotating in a circular path. Okay, circular path. Now we will answer the questions one by one. Is the velocity of a stone uniform or non-uniform or a variable? Listen, whenever an object is rotating in a circular path, velocity is a variable quantity. So velocity is variable, it is not constant. Okay, for A, velocity is variable. Next, is the acceleration of the stone uniform or variable? We know acceleration depends upon velocity. If velocity is variable, then acceleration is also variable quantity. Acceleration is also variable. Now the third question, what is the direction of acceleration at any instant? What is the direction? See, direction, okay, why there is a acceleration is produced, because of which force? It is because of centripetal force. What is the direction of centripetal force? It is towards the center. Acceleration, there are, see, understand the question. What is the direction of acceleration? Acceleration is produced by centripetal force. So direction of centripetal force is nothing but the direction of acceleration. So that will be towards the center. Okay, towards the center. Next, fourth question, which force provides the centripetal force required for the circular motion? For centripetal force, something has to provide it, correct? Someone has to provide it. Here, not someone, something. We are using a stone, right? So this stone is attached to what? String. This string has a tension and a friction. The friction and the tension of the string, the friction and the tension of the string is providing the necessary centripetal force. So tension and friction of the string. Okay, the final question, name the force and its direction which acts on the hand. On the hand. So we got to know centripetal force is acting towards the center. It is not on the hand. It is not on the hand, towards the center. See, assume this is the circle. Okay, the centripetal force will be directed towards the center, but they are asking what is the force which is acting on the hand. If centripetal force is done, the remaining thing is centrifugal force. Okay, centrifugal force will be acting on the hand. So answer for the fifth one, okay, is centrifugal force, and the direction of centrifugal force will be away from the center of this circular path. Okay, the answer for the fifth one is centrifugal, and direction will be away from the center. I believe you have learnt everything, so this much is enough. If you know all these things, then you can think the complete concept is in your pocket. Thank you.